Today we're going to extend our work with histograms to describe the data distributions they display. We have two objectives today. They are that we can construct a relative frequency histogram and that we can recognize that the shape of a histogram constructed using relative frequencies is the same as the shape of the histogram constructed using frequencies. Let's look back at our frequency table from lesson 4. This table counted the frequency of cap sizes for the 6th grade baseball team. And that's just what a frequency table does. A frequency table is a table that lists data and shows the number of times the data occur. But sometimes we want to know the relative frequency of a data set. Relative frequency is the frequency of an interval divided by the total number of data values. This is often represented as a fraction or a percent. Let's revisit our table and update it to include relative frequency. Add a new column to the right of your frequency table. Title this column Relative Frequency. Because relative frequency compares the number of data values in an interval to the total number of data values, we should also record the total number of students on the team. In this example, there were 40 students. Let's start by determining the relative frequency of extra small caps. Remember that to find the relative frequency, we divide the frequency of the extra small caps by the total frequency of the data set. In this case, we would divide 2 by 40. We would list these values as both a fraction and in its decimal form. The decimal form helps us understand the percent frequency because percents are simply fractions out of 100. Let's repeat this process to find the relative frequency of small caps ordered. There were 8 small caps ordered out of a total of 40 caps. This gives small caps a relative frequency of 8/40ths or 2/10ths in decimal form. Solve for the relative frequency of the remaining cap sizes in both fraction and decimal form. Pause the video here until you're ready to check your work. Good work! In yesterday's lesson, we used the frequency table to create a histogram that measures the frequency of each data interval. Today we're going to do the same thing, but instead create our histogram based on the relative frequency of each data interval. This was the histogram we created yesterday that represents the frequency of each data interval. Notice that the frequency is measured on the y-axis. To create a relative frequency histogram, we're going to keep our head circumference intervals the same, but measure relative frequency instead of frequency. This means that our y-axis and its values will change, but the x-axis will not. Let's create the relative frequency histogram on the right. Notice that the y-axis now measures the relative frequency of each data interval. Because we're measuring relative frequency, we need to adjust our y-axis values to decimals, fractions, or percents that measure the relative frequency of the data interval. Looking back at our table, we can see that the highest relative frequency is for medium caps with 375 thousandths, while the lowest frequency is tied between extra small and XXL at 500ths. This should help us plot values on our histogram. Let's plot our y values up to 40 hundredths, since this will be just above the 375 thousandths relative frequency of medium caps. From here, we're following the exact same steps we used to plot yesterday's histogram, but we're looking at the relative frequency of each data interval to determine how far it goes along the y-axis. Let's look at the relative frequency of extra small caps. Extra small caps have a relative frequency of 2/40ths or 500ths. Let's plot 500ths on our histogram for extra small caps. The data interval for extra small caps on the y-axis is between 510 and 530 millimeters, so that's where we'll plot our data. We'll draw a rectangle that reaches up to 500ths on the y-axis. Continue this process of plotting data for each cap size until you've completed the histogram, referring back to the relative frequency table you copied down. Pause the video here until you're finished with your histogram. Nicely done. Notice that our two histograms are identical except for the y-axis. This is because we're using the same dataset for each, so the shape of the data distribution doesn't change. We just measured it using two different methods. You're going to continue plotting and interpreting data in today's independent practice work.